Good day, everyone. So for week 3, we have the trigonometric functions of real number. For this topic, so we do have the subtopics, the region measure, followed by conversion of angle measure. We're going to convert degree to region, region to degree. Third, trigonometric functions of any angle. Then we have evaluating trigonometric functions. Fifth is the reference angle, and then lastly is the unit circle. For the region measure, so we have here a circle in a Cartesian plane in which the center of the circle is located at the origin of the Cartesian plane. So here you can see, okay, the description of the region, which is the measure of a central angle theta that intercepts an arc S, which is equal in length to the radius of the circle. Okay, and we have this formula. So as you can see in our circle here, okay, that if we have this radius of the circle, so from its center, okay, towards its circumference, so you can see that actually this portion is the initial side of the angle. And if the terminal side is going to rotate, so here's the direction, and then you can see here that this is the terminal side. And as what you can notice that the initial side and the terminal side are both in terms of R, or written as R. Okay, it is written as radius. And you can see here, so on the circumference that we have here, the arc S, and it is equivalent to the radius. So with the formula, so theta equals to S over R. So for theta, and with S equals to R, so we have this, if say that we have the same measurement for the arc and the radius, so theta is equivalent to 1. That is if S and R are equal, and you're gonna divide the S by the R. So this is to show to you the, well, so in how many parts are the circles divided. So since we are talking about the region measure, so how many regions are there in a full revolution? Okay. So actually, if you can still remember, when we discussed about the degree, okay, when we discussed about the degree, so for example, if this is our circle, so this is, well, so this is 0 degree, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then with a full revolution, we do have 360 degrees, okay? So for those of you who already know how to convert um, degree to region, so in converting, so for well, for the information of others, possible you already forgot. So just a review that um that a full revolution of 2 pi, actually this is the full revolution of the region. And if we have 360 degrees for the degree, okay, the 360 degrees for the degree, so this means that 360 degrees is equivalent to 2 pi. So this is in region. Okay. And in decimal, so this is 6.28. Okay. So that is also 360 degrees. 6.28 rods. Okay, 6.28 rod. So let us take a look at the circle. So how is the 6.28 can be shown here? So the yellow, that is the first, purple is the second, yellow green is the third, the blue is the fourth, the red is the fifth, the gray is the sixth, and then the green is the 0.28. Okay, so full revolution in terms of degree, 360 degrees. In terms of region, it is 6.28. Knowing that pi is 3.14 in two decimal places. Okay, so if you have 2 pi, so it is 6.28. Then now let us have the complementary angles. So same as what we discussed in the degrees, in terms of region, we also have complementary angles. So we have here an example. So in this example, okay, so what if you will be asked of what is the complement? What is the complement of the given pi over 8? Okay, so if you are going to graph it, so when you graph, okay, if you do not know yet how to convert to degree, so you can graph. Because there are those um who compute for the complementary by converting to degree first and then graphing. And then for some, you can graph, or if you know that well, that for example, if we have here 0, okay, then counterclockwise direction, the 90 degrees is equivalent to pi over 2. Then 180 is pi, 270 degrees is 3 pi over 2, and then a full revolution, that is 2 pi. If you already know the equivalent, or you it is easy for you to determine the complement even if without graphing, by just merely subtracting. So you may do so. Okay. So for the others, since we do have here a graph, so I'll show it how can this be done. Okay. So since the given is pi over 8 and we need the complement. When we say complement, so that is half of the pi. Pi is 180 degrees, half 180 is 90 degrees. Therefore, half of the pi is located in this, well, in this portion. So if you're gonna graph, how can you be able to graph? So you take a look at the denominator, okay? The denominator of the fraction is 8. So this means that you are going to divide the pi with, when I say pi, from 0 up to pi, you're going to divide it into 8 portions. Okay, you divide the upper portion, you consider just the half because you need the complement. Okay, another way is if you have this denominator, you divide this by 2. So it means that whatever will be the quotient, that is the number of parts in which um, the 0 up to pi over 2 will be divided. Okay, so let us take a look at this 8. So this means again that we are going to divide the 0 up to pi into 8 parts. Okay, so dividing it into 8, first quadrant, we are going to divide it by 4. So 1, 2, 3, 4. This is already 4. And then the second quadrant also by 4. Okay, as you can see, we have here 1, 2, 3, 4. So if you have a protractor, you have to measure it and then be sure that the parts are equal. Okay, So this means that from 0 up to pi, we do have 8 parts. Now, since the given is pi over 8, this means 1/8 of pi. So that is what you are going to graph. So 1/8 of a pi, so you're going to count 1. So this is the first. So this is actually your given. So that is your pi over 8. Actually, it is already written here. Okay. Next, since we need a complement, so the complement in degrees is 90 degrees. So we're going to look at here, okay, which is equivalent to pi over 2. So remember that for the complement, the sum in degrees should be 90 degrees, okay? Two positive angles, when you add, the sum should be 90 degrees. In radian, okay, if you have two angles, alpha plus beta, the sum should be pi over 2. So in this case, graphically, you can actually identify. So how many? So you just count 1, 2, 3. Okay, so we have 2, 3, 4. This number's 2, 3, 4. But then you have to count 1, 2, 3. There are 3 parts. Okay, so it is 3 pi over 8. The complement is 3 pi over 8. What you can do with this, if you would like, so that is pi over 2 minus the given pi over 8. Then you'll have the complement. Okay. So let us have another example. So I'll switch to the black screen. For another example, so what if you will be asked of the complement? What is the complement of pi over 4? Okay, so graphically, so we have 0, then we have here pi, then half, okay? On the other side, we do have pi, so that is on the left. So half of the pi, so it will be written on the upper portion, so that is pi over 2. On the lower portion, or at the bottom, we have 3 pi over 2, then complete revolution of 2 pi. Okay, next, take a look at the given. The given is pi over 4. It means that the denominator is 4. We're going to divide pi into 4. Remember, our pi is on the 180 degrees. It is on the left. So we're going to divide 0 up to pi into 4 parts. So dividing it, so you use your ruler, your protractor. So we have here 1, 2, 3, and 4. But then remember, what we need is a complement. So we're just going to look on this portion. And then what we need is pi over 4. So pi over 4, this means 1 over 4 of a pi. So your 1 is here, so it means that this is the given pi over 4. And then since what we need is only up to pi over 2, so you count the number of parts left. So that is only 1. So that is pi over 4. This is the complement. So the answer is pi over 4 is the complement of pi over 4. Another easy way of identifying the complement is just by subtracting the given pi over 4 from pi over 2. I'm showing to you, well, how you can graph. Okay, next. So on the next portion, so if we have supplementary, we also have, if we have complementary, we also have supplementary. So remember that in degrees, so when we say supplementary, if we have, okay, just a review. So if we have alpha and beta, the sum should be 180 degrees. But then in radian, as what you can see, so the 180 degrees is equivalent to pi. So same procedure as in complement. The only difference is the sum, and just take note that the two angles should be positive. Okay, so if you will be asked of the complement of the given 5 pi over 6, okay, so the same. So graphically, you can identify it. So divide pi, 0 up to pi, by 6. Okay, so when you divide it, so it means that the first quadrant, we can divide it into 3 equal parts. So do not forget to use your protractor, then your ruler, okay? So we have 6 equal parts, okay? Then, so we have here 1, 2, 3. The middle is also, well, we have a partition there. 4, 5, and then 6. Then from the given, so we have 5 pi over 6. So we're gonna count 5 parts. So 1, 2, 3, 4, and 5. Okay, so to answer the supplement of 5 pi over 6, so as what you can see, the remaining, this portion, so you count it, it is 1. So that is 1 over 6 pi, or that is pi over 6. This is the supplement. Another way of solving for it is just by subtracting the given 5 pi over 6 from pi. Okay. Another example, so I will switch to the black screen. Okay. Supplement of 7 pi over 12. Okay, so remember that in determining the complement and supplement, both angles should be positive. Else, if one angle or if the given is negative, so your answer would be none. Okay, so let us determine this graphically. So we can graph, okay? So we have here 0. Remember, this is 7 pi over 2. So let us just label first. So we have here pi over 2, pi, 3 pi over 2. Then we do have here 2 pi. And then from the given, so the denominator is 12. So this means that we're going to divide the 0 up to pi into 12 equal parts. So if we have two quadrants on 0 and pi, 0 to pi, so it means that we can have 6 parts per quadrant. So dividing the first quadrant into 6, so let us start with having 3. So you just use your protractor so that you will have equal parts. Then, so 3. Okay, so with if you're gonna draw in a graphing paper or in any paper, use protractor. So we're gonna divide the second quadrant also into 3 first, and then making it 6 parts. Okay, so let us check if this is 12. Actually, no need to number. As well as the lines, when you draw, it can be well, it can be invisible. Okay, maybe you can just make use of markings, but then do not make lines like this, because I'm just well, I'm just having the lines here so that you can see. Okay, so this is only for discussion purposes. Okay, so let us count if we do have here 12 parts. So the first quadrant should have 6. So 1, 2, 3, 4, 5, and 6. So we have 6 parts in the first quadrant. Then let us continue. 7, 8, 9, 10, 11, and then 12 up to pi. Okay, so for the given, how many parts do we need? So in the given, what we need is 7. Okay, so we have 1, 2, 3, 4, 5, 6, 7. So that is the 7 pi over 12. And then what we need is the supplement. So for the supplement, let us just count 1, 2, 3, 4, 5. So 5 pi over 12. 1, 2, 3, 4, 5. 5 pi over 12. This is the supplement. Okay. So when you write the complementary, the supplementary, so um, just write how many parts. Okay, that's it. Okay, I'll go back to the PowerPoint. Okay. So the next thing that we have, coterminal angles. So again, so the same as the degree. So remember that in the degree in our discussion, so in determining the coterminal angle, um, one way is to determine the angle, okay, with the same terminal side as the given, in which the said coterminal angle will be of the opposite direction. Or another way is having the same direction, okay? So with this, as you can see, so the given here is 17 pi over 6. So 17 pi, so we do have the denominator of 6 if you would like to graph it. So we have denominator here of 6. So it means that we're going to divide 0 up to pi into 6 parts. So we have 1, 2, 3 here, 4, then we have here 5, then we have here the 6. Okay, so we have 1, 2, 3, 4, 5, 6. But then remember what we need is 17. So since we have 6 on the upper portion, to have for us to have 17 parts, we need to continue. Okay, we have to continue on the lower portion. So it means that from pi up to 2 pi, so we're also gonna divide it into 6 parts like that. So let us continue numbering. So 6, 7, 8, 9, the middle is included, 10, 11, 12. Okay, we already have 12. But then we need 17. So continue. 13, 14, 15, 16, 17. Okay, class. When you graph, again, no need to include these numbers. This can be invisible as well as your line. So you can have just small markings on your paper when you count. Or you can just count even without markings. That is up to you. Okay, so this is 17. So as what you can see, the rotation of the angle, okay, from the positive x-axis, so counterclockwise, so until it reached 17, part 17. Okay, so that is the 17 pi over 6. Next, so what is the coterminal of it? So as what you can see in our example, so remember it can be of opposite direction or the same direction. But then in this case, since since we have more than one revolution of the given, so most likely we can have the same direction. So if it is the same direction as what you can see, so we have here 1, 2, 3, 4, and 5. So that is 5 pi over 6. If ever another another option is that, so from the initial side, okay, let us count 1, 2, 3, 4, 5, 6, 7. Okay, so we can also have a coterminal on the opposite direction. So 1, 2, 3, 4, 5, 6, 7. That is 7 parts over of 12. But then the direction is opposite, so we have negative 7 pi over 12. That is another coterminal. Okay, so that is for the example. Before we go to conversion, let me give another example for the coterminal. Okay, what if there is a given, what is the coterminal of negative, okay, let just make it positive, 7 pi over 5. Okay, so graphically, we can again determine it. So since we have a denominator of 5 here. So let us first divide the 0 up to pi into 5 parts. 5 parts. So 0 up to pi. So 5 parts, well, can have this as the third, first and the second, fourth and the fifth. Okay, so let us number it. 1, 2, 3. 3 is at the middle. Okay, this line is included. This y uh positive y-axis. Then we have here 4. That is the positive side of the y-axis. Then we do have here the fifth. Okay, so in the given 7 pi, so it means that our well, the 0 up to pi is only 5, so we need to add. So we have to divide the other half, the pi up to 2 pi into 5 again. Okay, so we have your 6, 7, 8, 9, and then 10. Okay, so let us put 8 at the middle. Okay, and then what we need is 7. So since this is positive, so we have we can draw it counterclockwise, or we have to draw it counterclockwise. So we have here 1, 2, 3, 4, 5, 6, and 7. Okay, so that is the 7 pi over 5. So determining the coterminal, so we can just have the opposite. So from the initial side, so 1, 2, 3. So that is 3 parts of 5. The rotation is clockwise. So we have here negative 3 pi over 5. Okay, let us now go back to the PowerPoint. Okay, so the next subtopic is conversion of angle measure. So this is only a review, okay, since you already discussed this in your high school. So converting degree measure of an angle into region. So the formula is the given angle in degree, then multiply it 2 pi rad over 180. Okay, class. Just a reminder, okay? So if you have pi, so we can actually write it even without unit, okay? Rather if you have rad, okay, if you have rad. So in region, when the angle is in region, possible you can have the unit rad or not. So it means that if you are given an angle without a unit, it is understood that it is in region. Because if you're given an angle having this circle, it means degree. But then if you're just given an angle without any unit, that is region. Okay? So this means that the formula can also be theta times 2 pi over 180 degrees. Okay? Then region to degree, okay? So the given angle times 180 degrees over pi. Or that is, okay, with the red, okay. Or that is pi times 180 degrees over the pi, okay. So you would notice that if the given angle is in degree, okay, you're going to multiply it to a fraction in which the denominator has degree. That is, of course, you can cancel the unit. The same with having a region converting to degree. So the angle in region, you're going to multiply it to a fraction in which the denominator is in region. Even if you're just going to make use of the pi, so just think that the pi has a unit region in the formula 180 degrees over pi rad. Okay, so let us have examples. So convert the following angles to region. Okay, so the given here is 135 degrees. Okay, so you write the given 135 degrees. Let us multiply this into a fraction in which we can cancel the unit. Since the given angle is in degrees, so we're gonna multiply it into a fraction in which the denominator is also degree. Okay? So between pi and the 180, so it is the 180. Then put the pi on the numerator. And then we can already cancel. Okay? So we have here 135 pi over 180. Then just simplify this. Okay, so the 135 pi, this is equivalent to 3 pi over 4. Okay, if you want, you can also write this with the unit for region. Okay, so that is 3 pi over 4 rad. But then without the unit, it is also accepted. Okay, next example. So you just write a given. So again, multiply it to a fraction in which you can cancel the unit degree. So since the given is in degree already, so multiply it in which, well, multiply it to a fraction in which the denominator has degree. Okay, so we can cancel the unit degree. So we have here 540 pi over 180. Okay, so this can be reduced or, well, this can be simplified as 3 pi. Or with the unit, so we have 3 pi rad. Okay, next. So the next one, negative 270 degrees. So same process. So pi over 180 degrees. So cancel the unit. We have negative 270 pi over 180. This is also equivalent to negative 3 pi over 2. Or that is negative 3 pi rad. Okay. So I will now clear the screen for the next 3 examples. So convert 2 degrees. So we have here negative pi over 2. Okay, so the negative pi over 2, so negative pi over 2. So you have to multiply it into a fraction in which you can cancel the unit rad. So just think of it that this pi over 2 has a unit rad. So it means that the denominator should also be in pi rad and numerator is in degree. Okay, so we can actually cancel the pi here. So after canceling, so we have negative 180 degrees over 2. So this gives us an answer of negative 90 degrees. Okay, next, 9 pi over 2. So this is 9 pi over 2. Multiply it to a fraction with denominator that has rad. So that is the pi. Just a reminder, pi is not the unit of region because pi has an equivalent value which is 3.14. The unit of region is rad. So just to complete this, so 180 degrees. Okay. We can then again cancel the pi. We are not canceling pi because it is the unit. Okay. It is also the same as a number. If you have the same number on the numerator, denominator, you can cancel it. Then we can also cancel this portion, this one. So 2 and 180 degrees. So that will become 90 degrees. Okay. So 9 times 980. So we have 810 degree. That is 810 degrees. Next. So on number 6, you would notice that it is only a number. So as what I said a while ago, so if you only have a number, this means it is radian. Okay. So what are we going to do with this? So that is 2 times. So since this is in radian, so you're going to multiply it to a fraction in which the denominator has rad. Okay. So we have here So we have here 114.59 degrees. That is the answer. Okay? So 2 times 180 degrees divided by pi. Since this is in degrees already, so you have to write your answer in decimal. Okay, so that is why it is 114.59 with the unit degree. Okay. Next, for the next subtopic, which is trigonometric functions of any angle. Okay, so we are done with the 6 trigonometric functions. So this time, this is considering, well, the Cartesian plane. So you can see the x and the y, and then considering a point. Okay, a point which can be on any of the quadrants, and well, you have to identify the coordinates of the said point. If the if you well, you have to identify the x, the y. Okay, the x and the y, these are also called abscissa for x and ordinate for y. And since we are talking of the angle, well, so you can see here in our illustration here. So other than the point, okay, other than the point, because here well, possible we do have a point here, okay, in which we have the coordinates x and y, and then you can also see the radius, okay, from the center or from the origin towards the point. And then you can see here the angle. Okay, you can see here the angle. So this is an angle in standard position. So for sine theta, so as what I said a while ago, so if we have x, this is also called the abscissa. The y is called the ordinate. Okay. And then we have the hypotenuse. The hypotenuse of this is denoted by r, which is the radius. So since we discussed that sine theta, okay, so since we discussed before that sine theta is equivalent to opposite over the hypotenuse, so considering the angle, so for example, well, we, we can actually draw, we can actually create a right triangle here by putting a vertical line or a perpendicular line that we can create that. And in that case, so as what you can see, um, well, if we try to identify which is x and which is y, so of course, this portion, okay, the 0, okay, to here, or and then from this portion, okay, where the point is located, then measuring vertically up to here, okay, along the x-axis. So this is actually our y. So since we have the theta here, okay, since this is the theta, it means that um, the opposite side of theta is actually y. So this is the opposite. And y is called ordinate. So since sine theta is equivalent to opposite, so it means equivalent to ordinate, then divided by the radius is the hypotenuse. So that is why sine theta equals to ordinate over the radius. Or we can also say that it is y over r. This time you have to memorize or you have to take note of the x, the y, and the r. Again, this time you have to take note of the x, y, and the r. Okay. Next, for cosine theta, it is abscissa over the radius. So with our illustration a while ago, okay, so since the theta is here, so the side that is beside it is the x, which is called as the abscissa. So since cosine theta, okay, so remember, since cosine theta is equivalent to adjacent over the hypotenuse, and in our illustration a while ago, the adjacent is the x, also known as the abscissa, and then hypotenuse is the radius. So we have abscissa over the radius. Also, what? So it can also be written as x over r. That is for the cosine. For the tangent, so based on our discussion last week, so the tangent theta is opposite over the adjacent. So since the opposite is well y, so that is the ordinate, and then x is the adjacent, so that is the abscissa. So tangent theta is y over x. So for the reciprocal, so we have got tangent theta. So abscissa over ordinate or x over y, since tangent is y over x. Secant theta is radius over abscissa or r over x, since cosine is x over r. And cosecant is radius over ordinate since sine is what? Since sine is ordinate over the radius, or since sine is y over r, therefore cosecant theta is r over y. Okay, let us have here an example. So determine the values of the six trigonometric functions. So for this example, so what we're gonna do is since we do have a measurement here of 45 degrees, then we do have your x equivalent to 1, then y equivalent to 1. As what you can see, this is an angle in standard position with the vertex at the origin. We have here the x-axis and then the y-axis. Then if we have x, y, so this is our r, which we do not have um, the measure yet. Okay? So in order for us to solve for r, okay, remember r is important for the six trigonometric functions because there are trigonometric functions that need r. Okay, so for r, so remember that the sum of the squares of the two sides is equivalent to the square of the longest side, which is the hypotenuse. Okay, so let us derive the formula for r. So let us write first r on the left side. So we have r squared equals to x squared plus y squared. And for us to get rid of the square here, so we can extract the square root. Okay, same with our discussion before. So we have your r equals x squared plus y squared. And remember, we cannot cancel the square on the right side because we do have the operation addition. Okay, so now let us substitute. So x is 1, y is 1, therefore r is square root of 2. So with the values of the x, the y, and the r, we can now solve for the six trigonometric functions. So I will switch to the black screen. So with x equals to 1, y equals to 1, and r equals to the square root of 2. So let us solve for sine of 45 degrees. So since we already have a value for the theta, so we're just going to write it. And knowing that sine is y over r, or ordinate over the radius. Again, ordinate over the radius. So we have y, which is 1, and then r, that is square root of 2. So as you can see, we need to rationalize this because the denominator has radical sign. Okay, so we have 1 times square root of 2 is square root of 2, square root of 2 times square root of 2, this is 2. Okay, so sine of 45 degrees is square root of 2 over 2. You can also check this in your calculator. Sine 45 degrees equals. Next, cosine of 45 degrees. That is x over r, or abscissa over the ordinate. So abscissa is 1. Um, that is abscissa over the radius, rather. Again, cosine abscissa over the radius. So abscissa is x, so that is 1. And then r is square root of 2. Okay, so we can actually rationalize it again. So square root of 2, square root of 2. So 1 times square root of 2 is square root of 2 over 2. And then for the tangent, 45 degrees, tangent is y over x, so that is ordinate over the abscissa. So just substitute 1 over 1 equals to 1. That is tangent 45 degrees. Okay. Then we have the three reciprocals. So for the three reciprocals, it is up to you which one would you like to solve first. So I'll clear the screen now. Okay, so if you would like to solve for the cotangent theta, in which theta is 45. Okay, so we have cotangent of 45 degrees. Okay, so cotangent 45 degrees is x over y, 1 over 1 equals to 1. Okay, next we have secant 45 degrees, which is r over x. So we have r of square root of 2, x is 1. So we have square root of 2. That is secant of 45 degrees. And then for the cosecant 45 degrees, so that is r over y. R is square root of 2, then y is 1. Then cosecant of 45 degrees is square root of 2. These are the answers. Okay, so let us go back to the PowerPoint. Another example. Okay, so this time the angle is 60 degrees. Then we have x, which is 1. Then y is square root of 3. So the same, you need to determine the r first. Okay, so since we already have a formula for the r a while ago, so that is r equals square root of x squared plus y squared. Remember, we already derived this in the first example. So now let us substitute. So x is 1 squared plus square root of 3 squared. Okay, so we have here 1 square root of 3 squared is 3 plus 1 square root of 4. So we have r of 2. Okay, so we can already compute. So again, x is 1, y square root of 3, and r is 2. Let us go to the black screen. So x is 1, y is square root of 3, and then r is 2. So let us solve for sine theta. So sine theta is y over r. So y square root of 3, r is 2. So this is already the final answer. Cosine. Cosine, wait. So we already have the given angle a while ago, which is 60. So we're gonna make use of it. So that is 60. Sine 60, sine 60. Now cosine 60 degrees, okay? So we have the formula x over r. X is 1 and then r is 2. So we have cosine of 60 degrees, so it is 1/2. And then for the tangent, 60 degrees. So that is y over x. Y is square root of 3. X is 1. Then simplifying, tangent of 60 is square root of 3. That is the answer. Next, cotangent of 60 degrees equals we have x over y. So x is 1 and then y square root of 3. Okay, as you can see, we do have here a fraction in which the denominator has radicals. So we're going to rationalize this. Okay, so we do have the cotangent of 60. Okay, so cotangent of 60 degrees equals to square root of 3 over 3. Then the other two, we have secant of 60 degrees equals, secant is r over x. So r is 2, x is 1. So therefore, secant 60 degrees is 2. And then lastly, the cosecant 60 degrees. Cosecant is r over y. R is 2. y is square root of 3. Again, since we have radical sign on the denominator, so we have to rationalize this. And the answer would be 2 square root of 3 over 3. Okay, so that's it. So I will go back to the PowerPoint. Okay, going back to the PowerPoint. So now let us evaluate trigonometric functions. So in this slide, so I'm showing to you again the Cartesian plane. So you can see here the x-axis, you can see here the y-axis, and then we do have here, well, so what if we have a point on the first quadrant, a point on the second quadrant, or on the third, or on the fourth? So if there is a point on the first quadrant, remember, we are considering the angle and then the trigonometric functions, okay? So if we do have a point here, so this actually has the coordinates, okay, the x and the y. So when it comes to the sign, so the x is positive, the y is also positive. As what you can see, so x is greater than 0, so it is positive. Y is greater than 0, y is positive. If the point is on the second quadrant, so x is less than 0, it means that x is negative, and y greater than 0, so it means y is positive. So x negative, y positive. Second quadrant. On the third quadrant, so since both are less than, so we have negative and negative. And on the fourth quadrant, we have x greater than, so this is positive, and y less than, so we have here negative. So we have positive and negative. Okay. So we have here another illustration. So the quadrants, so 1, 2, 3, and 4. So you can see that the sine, cosine, and tangent on the first quadrant are all positive. In the second quadrant, only sine is positive, cosine and tangent are negative. By the way, if we have sine, cosine, and tangent, we are also considering the reciprocals. Okay, so it means that if, take a look at the second quadrant, so if sine is positive in the first quadrant, rather in the second quadrant, this means that cosecant, the reciprocal, cosecant theta, the reciprocal of sine is also positive. That's it. Then if cosine is negative, it means that secant is also negative. So secant theta, then tangent, we have cotangent. So these four are all negatives in the second quadrant. In the third quadrant, only tangent is positive as well as the cotangent theta. And in the fourth quadrant, only cosine theta is positive as well as the reciprocal secant theta. Okay? So to make it easier to, well, to remember this, I would suggest that you memorize the acronym A, which stands for all. All the 6 trigonometric functions are positive. And then S, on the second quadrant, it means that sine and its reciprocal are positive in the second quadrant. Then the others would be negative. In the third quadrant, you remember the T. It means that tangent and its reciprocal are positive in the third quadrant. And in the fourth quadrant, you take note of the C. It means cosine and its reciprocal are positive in the said quadrant. Okay. Next. So here is an example. Okay, so given theta equals to negative 3 over 4 and tangent theta is less than 0. So we're gonna solve for the cosine theta. Okay, so in order to solve this, so well, so you just take note first of the given. Okay, it is said that sine theta is negative 3 over 4. So if you're going to remember the ASTC acronym, okay, the ASTC acronym. So you have to determine in which of the quadrant or well, is sine theta negative on the first, the second, the third, or the fourth? You can have two answers. Okay, you can have two answers here. So sine theta is negative. So on quadrant 1, all functions are positive. So it is not here. In quadrant 2, sine is positive. So it is not also here. In quadrant 3, only tangent and cotangent. Oh, quadrant 3. And then in quadrant 4, only cosine and sine are positive. So it means that on third and fourth quadrants, sine theta is negative. Okay, next. You take a look at the next given, the tangent theta, less than 0. When we say tangent theta is less than 0, this means negative. So again, you're going to go back to the ASTC. Okay, so ASTC. So just analyze again. Tangent theta is negative. So on the first quadrant on A, all are positive. On S, only sine and its reciprocal are positive. It means that cosine and tangent are negative. So we can encircle this because tangent is negative in this quadrant. In quadrant 3, tangent is positive. But then, in our given, tangent is negative. So we cannot encircle this. In quadrant 4, only cosine and its reciprocal, secant, are positive. So it means that sine and its reciprocal, tangent and its reciprocal are negative. So we're gonna encircle this. Okay, so what's the next thing that we're gonna do? So we have to, well, we have to determine uh, what is the common quadrant? Okay, so let us list it. So we have quadrant 3, we do have quadrant 3 and quadrant 4. And then next, we do have quadrant 2, and quadrant 4. Okay, so what is common is of course quadrant 4. So it means that the point, okay, remember we need to determine where's the point located. Is it on the first, second, third, or fourth? The point has the coordinates x and y. So now, we already know where is the point located. It is in quadrant 4. But then, so we're done with the quadrant. The next thing that we need to know are the what? The coordinates. So when we say coordinates, the x and y. Okay, these are the next well, the next thing that we need to determine. Okay, then after that, if ever we can also solve for the r, so we also need to do so. So coordinates, then followed by r. Okay, so in determining the coordinates, let us take a look at first at sine theta. Okay, so sine theta is equal to negative 3 over 4. That is a given. And we know that sine theta, okay, we know that sine theta is y over r. Okay, y over r. So this means that we can already well, we can already identify the value of y and r. So always remember that y is always positive. Remember that. So since or rather r is always positive, okay, the hypotenuse is positive. So in that case, With this, so it means that r, because take a look at this, we do have here a negative, and we do not know if if the negative is with 3 or is it with 4. So only one number should have the negative. But then since r is always positive, so it means that r is 4, positive 4. So r is positive 4. And then y, remember that the x and the y can have negative. Okay, it can have negative. Actually, one can be positive, the other can be negative, or they can be both positive, they can be both negative. But then R is always positive. Just take note of it. Okay, so we have Y, that is negative 3. So Y is negative 3. Okay. So what do we know what do we need in this problem? We need the cosine of theta. Okay, so with the cosine of theta, so I'll switch to the black screen. Okay, so again, sine theta is equal to negative 3 over 4. And then we know that sine theta is equivalent to or is equal to y over r. Okay, so r is always positive. So this means that we have r that is equivalent to 4, and then we have y, which is negative 3. So since we need to solve for cosine theta, and we know that the formula for cosine theta is x over r, okay, we already have an r, which is 4. So what we need is x. So in solving for x, we're gonna apply the Pythagorean theorem. So in the Pythagorean, remember that um, that is x squared plus y squared equals to r squared. The other way around, we do have, we can also write this as r squared equals to x squared plus y squared. Okay, so what we need is the x. We need the x. So we're just going to transfer y squared to the other side. So with x here, so we have x squared equals to right side r squared. So moving or writing y squared to the other side, so it will become y squared. Remember to change the operation, it will become minus. So we have here x squared equals to r squared minus y squared. So we need to remove the square, so extract the square root. So we can cancel. So we have here, I'll just write it here. So x squared equals to, or rather x, because we already removed the square. Okay, so we have here x equals to the square root of r squared minus y squared. Then substitute square root of, so r is 4 and y is negative 3. Okay, so we have here x equals to square root of 7. So we have here 4 squared is 16. 16 minus 3 squared, so 16 minus 9. So we have here 7, then square root of 7. So x is square root of 7. So we have cosine of theta equals to square root of 7 over 4. So that is the answer. Okay. So if we are going to graph this, so I'll just erase this portion. If we are going to graph it, so this is the Cartesian plane. So x and y. Remember that the point is located on the fourth quadrant. So we have x, square root of 7. The square root of 7 in the calculator is 2.65. Okay, so that is 2.65. So let us find the square root of 7 in the x. So let us have 1, 2, 3. So 2.75 is somewhere here. Okay, so this is the square root of 7. We're gonna put the radical because we converted to decimal. That is just to, well, to locate it in the Cartesian plane. Okay, next, we have y of negative 3. So y of negative 3 is located on the lower portion. So let us just divide it into 3. 1, 2, 3. So our negative 3 is here. So 1, 2, 3. Okay, so this is the point of intersection. As what you can see, so this is square root of 7 and then negative 3. So the point is located in the fourth quadrant. So for us to see here the angle, so what we have to do is just to draw a line. Let us draw a line from the origin towards the point. Okay, so this is our R that is equivalent to 4. And then we're gonna put the theta. In putting the theta should be in between. Okay, it should be in between the terminal side and the x-axis. So this is our theta. Again, remember, the theta is put, okay, between the terminal side and the x-axis. X-axis, not the y-axis. Okay, again, the theta is put in between the terminal side and the x-axis. Okay, next, let us go back to the PowerPoint. On the second example, so given tangent theta equals to negative 5 over 4 and cosine theta is greater than 0, we're going to find sine theta and secant theta. Okay. So the same thing that we did a while ago. So for the given, the first given, so we have two givens here. Okay. So for the first given, let us consider the ASTC. Okay. So tangent theta is negative. So determine in which quadrant is tangent theta negative. So on the first, it is positive. On the second, only sign is positive. The rest are negative. So we can encircle this. On the third, tangent theta is positive. So not this quadrant. On quadrant 4, only cosine theta and its reciprocal is positive. The rest are negative. So it means that we have quadrants 2 and quadrants 2 and 4. Okay, 2 and 4. Next, on the second given, so we have here cosine theta greater than 0. So ASTC. Cosine theta is greater than 0. This means that cosine is positive. Okay, cosine is positive. So let us determine the two quadrants in which cosine is positive. So, okay. So, cosine, so on A, all are positive. Okay. Second, only sine is positive. No. So, third tangent, only, well, T tangent is only positive. So, it is no again. Then, on the third quadrant, so C, cosine is positive as well as its reciprocal. So, okay, we're going to encircle it. So it means that the quadrants are quadrants 1 and 4. So just determine the common quadrant. So we have quadrant 4. Okay. So since we are already done with the quadrant, okay, we are already done with the quadrant. So what we need are the coordinates x and y as well as the r. Okay, so these are question marks. So we're gonna take a look at the given -5/4 here for the tangent. So since we do have the given tangent theta equals -5/4, so think of well, just remember that the negative, we do not know if it is on the numerator or denominator, so you just put it in between. Okay, so remember that tangent theta is y over x. I'll just rewrite this one. So tangent theta, okay, equals to -5/4 equals to y over x. So since y and x can be either positive or negative, okay, both can be positive, both can be negative, or one is positive, one is negative. So we do not know yet, okay, if we have x equal to -4, equals to -4, or y equals to -5. So what are we going to do if we cannot tell? So let us go back to the quadrant. Okay, remember that the point can be located at the fourth quadrant. So if you can remember our discussion a while ago in which I showed to you the quadrants, and then if you have a point on quadrant A, a point on or rather a point on quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So by with that, so we already know the coordinates. Okay. So since at quadrant 4, okay, so we do have the coordinates of x and y, which are um, positive. X is positive and then y is negative. So we can easily say, okay, in which number? Is it on 5 or 4? We are going to put the negative. Okay, so with quadrant 4, so x is positive, y is negative. So it means that in our given, so it means that x is positive. So x is 4. Okay, so x is 4. And then y is -5. So y is -5. That's it. Okay. Then we can already solve for the r. Okay, so I'll switch to the black screen. So since we have again tangent theta equals to -5/4, and since in quadrant 4 we know that x and y, the coordinates are positive and negative, so we can easily identify, okay, we can easily identify or determine the values of y and x. Okay, so remember tangent theta is y over x, so we can easily determine. Okay, so x is 4, and then y is -5. So y is -5. So we already have the coordinates. What we need now is the measure or the value of r. So r. So how are we going to solve for r? So again, by Pythagorean. So we know that r squared equals to x squared plus y squared. So r equals to the square root of x squared plus y squared. So substituting, so we have x is 4 and then y is -5. Okay. So therefore, so we have r equals to the square root of, so we have, so 4 squared, that is 16, plus negative 5 raised to 2, this is 25. So we have 41. So r equals to the square root of 41. Okay? And again, what we need in the problem are, so what we need in the problem are sine theta. So sine theta in our formula is y over r. Since y is negative 5 and our r is square root of 41, so we're just gonna rationalize this. So square root of 41, square root of 41. So we have sine theta equals to negative 5 square root of 41 over 41. Okay, so this is the final answer. By the way, class, when it comes to your answer, the negative can be put in between the numerator and denominator. You can put it in the numerator or you can put it in the denominator. That is for the final answer. But then well, just like in our analysis a while ago, where are we going to put the negative, because we need to determine um will it be on the y or the x. So that is the reason why the placement of the negative is really important. Although this is still fraction, so you can still put the negative in between numerator and denominator. But then deciding where you are going to put it, so you have to consider the quadrant, okay? And the signs of the coordinates. Okay, next. So let us solve for the other unknown. The other unknown is the secant theta. So I'll just erase this portion. Um, secant theta equals to r over x. So just substitute. Our r is square root of 41 and then x is 4. So that is the secant of theta. This cannot be simplified anymore. Therefore, this is the answer. Okay. Next, let us go back to the PowerPoint. Next topic is about the reference angle that is denoted by theta prime. So if we have an angle, so that is a theta, if you will be asked of its reference angle, you're just gonna put prime. So the reference angle is an acute angle between the terminal side and the horizontal axis. It is acute. The reference angle is acute. It is less than 90 degrees. And another thing, the reference angle is always positive. Okay? So what does it mean? If you have an angle, whether positive or negative, when you are asked of the reference angle, it is always positive and acute. So this is how, well, when it comes to the quadrants, so as what you can see in quadrant 1, okay, so the given angle, the measurement of the angle is also the reference angle, or same with the reference angle. In quadrant 2, so in quadrant 2, the given angle is in red, its reference angle is in blue. Okay, so because you need to measure the angle between the terminal side and the horizontal axis. In quadrant 3, so in quadrant 3, the angle is in red, and then the reference angle is between the terminal side and the horizontal axis. So this is quadrant 3. And in quadrant 4, so the angle is in red again, and then the reference angle is between the terminal side and the horizontal axis, or the x-axis. X. So let us find the reference angle, theta prime. So the given angle is 300 degrees. Okay, so if we're gonna solve this graphically, so let us just graph. Okay, this is 300 degrees. This means positive. So we have your 0 degree, again 90 degrees, 180 degrees, 270 degrees, 360 degrees. So graphing the 300, so it is actually in quadrant 4. Okay, so we have it here. You just use a protractor so you can have the the accurate measurement, the exact measurement. Okay, so this is 300 degrees, and again, if we are asked of the reference angle, um so the reference angle is again between the terminal side and the horizontal axis or the x-axis. This is the x-axis, so you're just gonna measure this. So that is so 360 minus 300, the reference angle, okay, is 60 degrees. This is the answer, reference angle. Next. Another example is the 2.3. Remember, if the given angle doesn't have a unit, it means that it is radian. Okay? So what you can do with this, if you would like to graph it, you can convert this to degree first. Or if you want, you can just, just identify it um, in the Cartesian plane. Okay, so we have 2.3. Okay, so in conversion, as what we discussed a while ago, so since this is in radian, so multiply it with the fraction in which the denominator is in rad. So we do have here the pi, the numerator is 180 degrees. So 2.3 times 180 degrees over pi is 131.78 degrees. Okay, so if we are going to graph this, so we have 131. So this is 0. This is 90, 180, 270. 360. And what we need is 131 only. So 131 is in quadrant 2. So it is here. Okay. So that is the 131. But then remember, it should be in rad. So let us just put the, so this is 0. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And then this is 2 pi. And then this is 2.3. Okay. So what we need is the measurement of the what? The terminal side and the horizontal axis or the x-axis. So this is actually what? So this measures 0.84. So this measures 0.84. So why is it 0.84? Remember, you have a pi here, and then pi is 3.14. So 3.14 minus the 2.3. That's it. Again, pi minus 2.3. The answer is 0.84. Or if you would like, with a 131.78, so that is 180 degrees minus 131.74, and then the answer, you convert it back to rad. So your answer would be 0.84. Okay. So we're gonna have the next. So the next one, so I'll just remove the writings. Okay. So the next one is negative 135. The negative 135 degrees, if you are going to graph it, so that is negative. So it means that we have your 0. So negative is clockwise, negative 90 degrees, negative 180 degrees, negative 270 degrees, and then this one is negative 360 degrees. So we need the negative 135. The negative 135 is located in the third quadrant. So it is actually in between. Okay. So from the positive x-axis, so clockwise, negative 90. So this is negative 135. And again, in determining the reference angle, so this is the terminal side, and then this is the horizontal axis. So you just measure the angle on this portion. So that is, well, that is 45 degrees. So that is the reference angle. Why is it 45 degrees? Of course. So you're just gonna get the difference of the negative 180 and negative 135 degrees. Okay, the distance. So that's it. And then last subtopic is the unit circle. So the unit circle looks like this. It is a set of points equidistant from a fixed point that is called the center and has a radius of 1. Okay, so this is the center, and then you can see this is the circle, and it is said that the radius is 1. So as what you can see, if we have here a point, so the coordinates of this are 1, 0. So this is our x, and then this is our y. It means that the distance from the origin up to this point measures 1. So since this is our x-axis. Okay, then same with this point, okay, along the y-axis. So the coordinates are 0 and 1. 0 is for x, 1 is for y. So it means that from the origin up to this point, okay, along the y-axis, the distance is 1. So same with these two other points here. So that is actually the characteristic of a unit circle. The radius is 1. So unit. Okay. So what are the things to know? Points around the circle are equidistant to the center. Okay. It is very obvious in the illustration and has a measure of 1 unit because the radius is 1. And then the sine value of a degree is equal to its corresponding ordinate. Okay, so what does it mean? The sine value equivalent to ordinate. For example, um, say this at this point, okay? So if we have sine, okay, you copy the angle, so sine of 0, okay? Since we have here the point with the coordinates x and y, and remember that x is the abscissa, this is the abscissa, and y is the ordinate. So in the things to know number 2, the sine value of the said angle is equivalent to the ordinate. So it means that you're just gonna copy the ordinate here. So sine 0 degree is 0. Okay, so you can try to check it on your calcu. So you input sine 0 equals 0. Another example, say that we want to consider this point. Okay, so this point has the coordinates negative square root of 3 over 2 as the abscissa and negative 1/2 as the ordinate. Okay, so let us write the sine. And then this time, instead of degree, we have here the degree. But then let us make use of the rad or the region. So we have sine 7 pi over 6. So in using this unit circle, so the answer is the ordinate. So the answer is negative 1/2. Okay, negative 1/2. Why is it? Well, You can actually check this in your calculator. But then when you check this in your calculator, the angle with red, you have to um you have to make sure that the mode of your calculator is in rad. Then you can input sine 7 pi over 6. So change the mode of your calculator. You have to practice using your calculator how to change the mode. Remember, it will depend on the model of your calculator. There is a piece of paper that is attached to the cover of your calcu so that you know how to change the mode. If the piece of paper is missing, you can search it online. Okay, search it online. Just input the model of your calcu. So that is sine 7 pi over 6 equals sine. So the answer is negative 1/2. Okay. Next. So cosine value is the cosine of an angle is the abscissa. Okay. So for example, let us have the cosine of 120 degrees. The cosine of 120 degrees is what? Square root of 3 over 2. Remember, here is our 120 degrees, this point. This is the x, and then this is the y. And then the, correction. So, the abscissa is the x. Okay, just to correct it. The abscissa is the x, so the cosine of 120 degrees is negative 1 over 2. Okay. Next, another example. If we would like this, so this is our x and then this is our y. So we have cosine of 330 degrees equals to the square root of 3 over 2 because x is square root of 3 over 2. The cosine 330 degrees, that is also equivalent to cosine of 11 pi over 6. Okay. Let us use the right. So that is 11 pi over 6. Okay. Next, the tangent value of a degree is equal to the abscissa over ordinate. So for the tangent, you're just going to divide. So for example, so I'll just erase this. Okay. For example, so this portion. Okay, so tangent of 180 degrees. So negative 1 is the x, 0 is the y. So this is the abscissa, this is the ordinate. So we have here abscissa is x. I think there is a correction here. It should be ordinate over abscissa. Let me correct this. So this is ordinate divided by the abscissa. Abscissa. Okay. Just to correct this. Because it should be y over x. It should be y over x. So this is y is 0, x is negative 1. So therefore, tangent of 180 is 0. You can try to check it in your calcul, but then you have to change the mode. So it should be degree. So tangent of 180, the answer is 0. You can check it in your calcul. Okay. In this portion, so we have 1, 0. So tangent of 0 degree. So 1 is x, 0 is y. So tangent, we have y over x, or ordinate over the abscissa. Y is 0, x is 1. So again, we have here 0. So try to check it. So tangent of 0 is 0. In the upper portion, so we have 0, 1. So this is x, this is y. So we have tangent 90 degrees, or tangent of 1/2. So we have y over x. So this is 1 over 0. So this is undefined. 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 Undefined is the answer. In your calculator, math error will appear. Undefined. So next, the cosecant, secant, and cotangent of a degree is equal to the multiplicative inverse of the sine, cosine, and tangent values respectively. So when we say multiplicative inverse, so you're just going to put 1 over, okay? So for example, for cosecant, so it is 1 over sine. Secant is 1 over cosine. And then, well, if sine is equivalent to y, therefore cosecant is 1 over y. And if for cosine, so since cosine is equivalent to x, so secant is 1 over x. And if tangent is y over x, therefore cotangent is 1 over y over x, or simply x over y. So you're just gonna make use of the coordinates here, the abscissa and the ordinate. Then number 6, in case of a given angle is not equal to any of the given degree measurement, you have to find its reference angle. Okay, so if you have, for example, more than 360, so say you have 420. So if you have 420, so 420, this is 360 um, plus 60, you have here 420. So you can make use of this reference angle, the 60 degrees, and then consider the coordinates. So for example, sine of 420 is equivalent to the square root of 3 over 2. So you can try to check it. So sine of 420 degrees is equivalent to, since this is sine, so we need the x, rather the y. Okay, the y, the ordinate. So that is square root of 3 over 2. In your calculator, you can try to check it. But then in the unit circle, square root of 3 over 2 is actually here on 60, which is the reference angle of the 420. Why is it that 60 is the reference angle? Remember, because this is the terminal side, then this is the horizontal axis, the acute angle. Acute angle between the terminal side and the horizontal axis. And then number 7, in case the reference angle is still not on the given degree measurement, you may use the given table here. Okay. But then if you have your calculator actually, so you can just use your calculator. So for example, so how are you going to use this table? So if ever that you do not have your calculus, say for example, sine of 30. So sine of 30 degrees. So the answer is actually the intersection, that is 1/2. Okay. Tangent. So if we have tangent, for example, 120, the answer is negative square root of 3. So that is tangent of 120 degrees. The answer is negative square root of 3. That is how you're gonna use the table. Your answer would be the intersection of the um, trigonometric function and the angle. Okay, so that ends the topic for week 3. Okay, thank you.